Now, on the penetration testing side of things, we know what works, we know how the attacks work, but how the attacks work on different types of systems is very different. So these are just a couple of different examples. If I have a browser-based system, I'm going to probably test a browser-based system differently than I'm going to test a desktop application. And I'm going to test that differently than I'm going to test a mobile device. And I'm going to test that differently than I'm going to test car. And I'm going to test that differently than software and some military type of installation. So the system itself, the business, there's lots of things that may drive how I do penetration testing. I know how the defects work, but that's not the only attribute that's really important for figuring out how I'm going to do the pen testing. There's lots of other things. What's important to my business, what kind of data is being stored there, what is the functionality of the system, lots of other things come into play. So we have a bunch of information about how stuff works, but I also need to know how I'm going to do the testing. And even within some of the platforms, how I test an iOS device will be different than how I test an Android device, which will be different than how I test a Windows 10 versus BlackBerry, and on it goes. It's great fun for those that are doing pen testing because truckload of job security, right? Keep track of all this stuff. So that's the what is it. How are we doing it? Well, two primary ways. One is tool driven, right? So the tools themselves are in fact very mature. It's a very mature space. The tools have been around for quite a while, at least in the software development universe. But there are a ton of factors to consider. And they run from cost, some are free, some are six-figure and higher. Of course, there's the capability of the tool. And the difference between capability and feature set, capability is what is the tool capable of doing? Does it have a single type of scanning engine? Does it have multiple scanning engines? What exactly can the engine do? There's the feature set, which is what is this? Is the tool being able to dump different types of reports? It's got certain kind of performance characteristics. There's a bunch of characteristics of the tool itself. How easy is it for the tool to be customized? So for people that are running the tool or running a tool, is it, just again, show of hands, commercial? Anybody running commercial tools? Have you customized those for your environment? Yeah. So if you buy a tool and then don't customize it, you're kind of shortchanging what the tool can do, and we'll kind of get to that in a little bit. But the tools have capabilities that you need to take advantage of. Tools right out of the box aren't going to be operating at their best efficiency. That's just a fact of life, right? They have to be customized for lots of different things. Your environment, maybe even per app, you may have to do some customizing on how the app behaves. And then, of course, how can the tool be deployed? Is it going to be running on a developer's workstation? Does it only run in a production environment, test environments, whatever? So these are different factors that matter for the pen test side of things. Maybe the penetration test is going to be driven by people. So option one, you're going to outsource it, right? You don't necessarily have the skills in-house, or you don't want to invest the time to develop the skills in-house, so you're going to outsource this capability of pen testing. Again, pen testing of all kinds of systems been around for a very long time. It's very mature in this environment. Same, not same, similar to the tool though. A lot of different factors that come into play. There's the cost of the people-driven side. Can it scale? If you've only got one app that's being tested once a year, no big deal. If you have 100 apps and need to be tested tomorrow, how are you going to do that? Can wherever you're outsourcing, do that? What about the quality? Do you trust the person that's doing it? Where are they located? Again, I don't know what kind of companies you work for, but some have regional requirements as to where the testers can be. Lots of different factors. You could also have it people-driven in-house. So if the people are in-house, well, number one, pen testers are kind of hard to find. It's a different skill set to be a pen tester. We all like to think we can, think maliciously, but that's not always the case. Most of us are actually pretty good people, and thinking maliciously is a little bit tricky sometimes. And of course, if you do develop those skills in-house, sometimes keeping those people are kind of hard because they just developed a skill that's pretty valuable, and sometimes you tend to jump ship. So just an unfortunate fact of life. But these are a couple different ways of doing the pen testing side. So on the secure code review, what do we know about secure code review? It is not the same thing as a plain old code review. Right? Code review makes sure that the requirements are being met and we're going to functionally do what we're supposed to do. Secure code review is making sure, to the best it can, that the code has actually been implemented without introducing security defects. It's totally different than a code review. Now, you may have things like checklists. Checklists are kind of good for, we want to look for these types of things, we want to avoid these types of things. So we can have these checklists for common gotchas, totally fine. Some of the frameworks we use, they publish secure coding guidelines. So that might be kind of interesting if we can get a hold of those secure coding guidelines. And in fact, we may even have some guidance that is driven by the language. So, there's things like CERT, which has got some best practices for C, and they've got Java for sure. There's other published works for different languages. So there's information out there at the language level, at the platform level, for things to do. But again, this is on the secure code review side. This is what we know. We know how to avoid certain problems in certain languages. We understand sometimes even that the pilot can play a role. It really depends on what we're talking about. But we have this type of information. On the tool-driven side, again, this is a very mature area. Still tons of factors to consider. So if we're talking about static code analysis tools, things like cost, things like capability of the tools, features, the languages, how easy is it to customize, all these things come into play. And these are huge factors. Again, if you're not customizing, just like with the dynamic analysis, if you're not customizing the static analysis tool, you are losing a ton of value of the product. So you certainly want to think about these types of things. How can the static code tool be deployed? Similar. It's going onto the developer's desktop. Is it going to integrate with your continuous build environment? There's lots of factors. You can't really use a tool that's going to take 2 days to scan your code base if you're releasing every 2 hours. It's not workable. So some tools will make sense, other tools won't. So you kind of have to figure out what the tool can do for you. There's the people-driven side of secure code review. So this has got some other kind of unique problems. For anyone who's actually done secure code reviews as a human, we have bad days, we have good days. Sometimes we see things, sometimes we don't see things. So myself and the person who sits next to me, even though we're going through the same checklist, we may interpret the checklist a different way, we're going to get different results. It's almost kind of, it's kind of normal that we're not going to see, quote, see the same types of problems. We're going to see things differently. And so that's just part of the beast. The third and kind of interesting place where some folks start with an SSI is the secure design review side of things. Another word for this, things like threat modeling, architecture analysis, you may have heard different words for this. So the secure design review, this is complementary to the other types of analysis. It's going to find different types of defects. Penetration tests will find different defects in code review. We'll find different defects in secure design review. Right? They're all going to find different things. So this is probably one of the more challenging types of analysis because it's really driven by so many factors. Code review, kind of platform language, you're kind of done. Penetration testing, type of system, how it's deployed, you're kind of done. Here, there's so many factors. All of those different types of systems come into play. All the different platforms come into play. Everything is in play, and it's just kind of compounding everything. How you're interacting with vendors, third parties come into play. Who are your threat agents that matter? There's just so many more factors that come into play for this. It makes this one of the tougher types of analysis, I think. So again, all the different things that kind of influence how this analysis is going to work, platforms, languages, deployment types, all these things kind of affect how we're going to do our design analysis. And of course, things like the risk rating of the system, where it's deployed. If you can imagine a system that's being deployed that's only accessible by, production staff, by going through a jump box in your data center, it's going to have a totally different, well, it should have a totally different threat model than your mobile application that runs on, Joe Consumer's phone, right? It's a totally different risk profile. So even if it had some shared code, the design effort of that thing through the jump box, that app through the jump box, should get a totally different level of effort than that mobile app, right? So we kind of need to understand a lot of different factors about how the system is being deployed and used, whereas when we're looking at a piece of code, the code review tool doesn't really know how the software is being used. You run it through a code scanner, and it tells you found a bug, didn't find a bug. Pen test, you could point it at this deployed system, or you can point it at a piece of software on a test bed, but if it doesn't know how it's being deployed, you don't really understand what the real risk is to it. So when we talk about threat modeling and secure design review, we start to bring in those other elements. So we get a better picture of what do we worry about, what do we really care about. So one of the big problems for this is trying to teach this. We have, we've run into some pretty tough situations trying to teach folks how to do things like threat modeling and how to do secure design review. Has anybody taught this inside of your organization to do this? Or have you guys just kind of learned yourself? So was it difficult? Was it easy? It's not easy. So at least +1. It's funny, we just had the metrics talk upstairs. Not that a universe of 2 gives you, the warm fuzzy, but I think if you talk to a bunch of folks, you're going to probably see this is difficult to teach. And not everyone can do this. And it doesn't matter that you have a software security background. You can have a software security background and not be very good at this. And one of the reasons we've seen where that is exactly the case is this tunnel vision that some folks get. You are an expert in SSL. And so you have a broad security background, but you're an expert in SSL. And so we've seen where these folks go and do a secure design review, and they just spend a totally disproportionate amount of time on SSL controls and completely miss the boat on a bunch of other things because they're focusing on their comfort level. We see the same thing with crypto specialists. They will focus on all the crypto wizardry and miss the boat on some other very big design issues. So you kind of have to try to figure out who are those people that get the tunnel vision and can't see the forest for the trees, and you try to teach them, that they're kind of focusing on just what they know, and maybe they can break out and do that. But again, it's not for everyone. So it's a difficult thing to teach, which sucks, but you have to do this stuff. I wish there was a great answer for it. So secure design review, how is this done? On the tool side of things, as far as I know, there is no tool-only option, and what I mean by that, I know there are tools that help do this. But if I hand a piece of code to a static code analysis tool, it will run. It will not run as good as it could, but it will run and it will find some defects. If I point a penetration testing tool at a website that's been built, it will run, it will possibly find things. I can make it better, but it will run. There is no design tool that I know of that can take some artifact and then crap out a threat model. There's no such thing. I have to tell the Microsoft threat modeling tool how to do, what the threat model is. A person has to be involved in the design. And I think that kind of ties back to the design can have so many elements that I have to explain to the tool how the system is laid out for it to figure out what's interesting, where are things like trust boundaries, who's connecting to what's the stuff I need to worry about. It needs to have that information. So, like I said, I don't think there's anything that can read artifacts that you've created and create this threat model or this secure design review for you. A person is going to be involved, which unfortunately, as you can imagine, opens up the door for all kinds of errors while that secure design is being created. Right? Did you go to the right level of depth? Has it got the right kind of analysis? Has it got the right components? Did you actually put things, where where components really are? This is kind of a problem of building the threat model or building the secure design review.
What tool are you using?
Sorry?
What tool are you using to do that?
Us personally, internal. We use Visio. I mean, it's Visio with stencils and layers. Yeah. Why? Which one are you using?
I don't know.
Oh, yeah. There's a Microsoft threat modeling tool. There's it's a representation of the system in some sort of form. We like a representation that's picture form, so we use Visio, stencils, and templates. Microsoft has got a tool which basically creates a bunch of objects that are connected in a diagram, but you have a number of attributes that are associated with it, where I can describe this as either a process or a data store or whatever. It's got its 4 things, and then it applies its drag technique to it. And there's some other tools out there that do things a little different, but I mean, most of them, as far as I know, are drawing a picture, representation of the system, and then you're annotating it with things that are important to you. So we built our own that are keeping track of things that are important to us, and Microsoft has theirs, like I said, but it's always a person that is deciding when is this a process that I need on my diagram? When is this a component that I need on my diagram? How does it connect? When does it cross the trust boundary? You're telling it all those things. And so it's just another opportunity for something to go wrong. Because whoever's making that decision as the user of the tool, they have to understand how the system is really built, and they need to understand software security to recognize this is important enough that I need it on my diagram. Because you can quickly get into the weeds and have 2,000 components on a not relatively complex system, and your design review is totally useless. Too much information. At least that's what we found. So other folks that are doing this, would you see similar things, or what are you using? I know there's some hands went up that were doing this.
Yeah, Visio.
Microsoft, they're out, yeah?
Visio.
Visio? Any other options? I mean, these are the only 2.
There's App Modeler.
Who?
There's an App Modeler that's a pay tool you can buy.
Which gives you how things are connected.
Same thing.
Yeah.
Same thing, it's,
Yeah, so it's all picture-based. I haven't seen a non-picture-based one, at least not in my experience. This is unfortunately where we are. We're way behind the maturity of things like static and dynamic code tools. I think I don't see that ending anytime soon. There's too many variables ahead of time that I don't need the tool to figure out. And if I'm going to explain to the tool what's important to me, even if I drew a picture of the system, if it's a picture of a mobile app, how I interpret threats to that mobile app are very different than the app that's run by the production person in a data center that can only be accessed by the production people. This is different.
So you said that the secure code review is kind of different than the code review. Is the secure design review separate and it's done by like a different architect or designer than?
So the secure design review is totally different than a plain old design review. Design review, you may have folks that are coming in. It's like, we're going to use our enterprise solution for identity management. We're going to use our enterprise solution for an ESB, and that's your way of building and designing a system. Your enterprise architects, and you'll also have enterprise architects that know security, and so they'll wear both hats. But a lot of the organizations that I've worked with, the enterprise architect works with somebody from the SSG, the software security group, because they have a different experience. The enterprise architect knows how to build enterprise class systems, but doesn't know everything about security. Security people know all about different types of attacks and the things that are going to potentially break the technology that the enterprise architect is using, but the 2 heads need to get together.
So maybe doing it together collaboratively.
Oh, absolutely.
Okay.
Yeah. Strongly recommend that.
Do you typically focus on the external interfaces outside of the application or internal?
No, well, it'll depend. So internal ones will matter just as much. So internal access will matter, especially in those cases, for example, where it's corporate users doing things to the system in some sort of a maintenance function, not production people. They're corporate users, whether it's your customer service rep, somebody from marketing, whoever. There's an entry point, but maybe you're on the corporate network. So the attack surface changes, totally different threat agents, but not production people. So yeah, those are absolutely in play. Yeah, and those, in any tool that I've seen, they allow you to display that accordingly with things like trust zones. So you have to have this notion of, when you're inside of this boundary, you have a certain layer of trust. So corporate users will be in a totally different zone than Joe Hacker and Joe User that are out on the internet. So they'll have different types of attacks, but of course, for those of us that are doing things like penetration testing, we want to pivot off the inside and get full access from corporate land. Which is okay, because you need to be thinking about attacks against the system that way, which is exactly what things like code review and penetration tests don't do. Or they don't do it if you don't have this piece of information. which is why if you're just doing like a pen test, without this, you are completely missing that angle of importance. That I can attack the system by pivoting off this other location. It's another way in. Same with business partners, same with communications with external entities, whether it's uploading or downloading information, you know, what kind of information is egressing from you, what kind of information is coming in, all that shit matters. So if you're not understanding how that's, you know, this into and this outer of your system, there's a big hole in the analysis that things like code review and pen testing will have zero chance of finding. Right, absolutely zero chance. I'll never find it.
So how do you plug in that data that you get from the secure design review into the next step of pen testing?
Well, so that'll totally depend on you. I mean, again, we have a way of doing it. When we have our attack surface figured out, so we understand who's talking to who, protocols that are in use, data that's flowing in and out, you know, asset flow, things like that. Again, even for other tools, you know where information is flowing. You can then start to think about this threat agent, this attacker, whatever your word is for the bad guy. How are they going to attack the system? I can then take that information. This attacker is interacting with the system at this point. This is the entry point, right? What's the attack surface? They're going after this asset, this piece of data, this piece of functionality, and they're trying to make this happen. I can hand that to a tester, a pen tester, and they can now focus on this part of the system. Here's the trust boundary. Here's the attack surface. Focus on here because the assets behind this are much more valuable than this other part of the system. Try to make this happen. Try to get to this functionality, because if you can break this security control, there's a lot of valuable information behind there.
So it's a manual process of writing a checklist based on what you got from the
Oh, yeah.
design review. There's not
Again,
to bridge those two together.
so Microsoft runs through a ton of Stride-like output that tells you all the Stride things you should think about. Everybody's familiar with Stride? The Stride Microsoft model: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. It will look for those 6 things always. So it'll tell you, these 6 things for this connection, for this type of data, here's what you need to worry about. But you then have to go through the hundreds of stuff that it outputs and decide not relevant, not relevant, not relevant, can't happen. So it makes it harder for you to forget about something, and it gives you a ton of work to go do afterwards to figure out what's relevant and what's not relevant. So you're using it. I assume that's what you're going through, because that's what everyone goes through. Yeah, that's the good and the bad of the tool, which is why some people do it differently. Yeah, there's no good tool out there. Sorry. Yeah, it sucks.
Also, in all this code review that you do, are you concentrating more on internet-facing applications, or are you also doing internal apps that your regular users do?
So this is going to be a corporate decision. I assume whatever somewhere inside of your organization, you have a risk classification system for your apps. Yes, maybe? So you've got some risk classification. So high-risk apps are, high-risk apps, you do it all. Yeah, whatever it is. So internet-facing, probably on the list. Internal-facing might be on the list, right? Depends what's behind the internal access. If it's internal access to a bunch of static data that's updated by marketing and it's not super interesting, probably not relevant. If it's an internal app that is, getting access to full customer data and doing transactions on behalf of users, sounds important. I don't know what your risk classification system would say, but your risk classification is probably going to be the first driver, and then it's up to your level of maturity to figure out what other factors can adjust your risk rating. I don't know what you're using for the risk rating. It's not just internet facing, it's not just about the data. It could be, what's the technology that's being used? What's the system that's being deployed on? Right? If it's a system being deployed on a device that is my device, there are certain attacks you just have to worry about. And so you have to do some of this activity just to understand, let's not put stuff over in this part of the attack surface because we know we can't control it. You absolutely can't control it.
Yeah, the reason I asked that is because if you are worried about code that's inside, only your internal users, if you were saying, then the attacker's already inside. they just have to go to the drive and copy the data. It's like, why worry about the code? You know, there's no code for them to exploit, they're already inside.
Oh, so there's multiple reasons to worry about the code. If it's internal code that is still like a website, for example, I don't have access to the data. I don't have access to the data sitting in your data center on your production database. But if there's vulnerabilities in the code that allow me to launch, again, pick your favorite, OWASP attack, SQL injection, process scripting, whatever, I can attack other users in corporate plan. I can maybe use an attack to get the data I'm not supposed to get to. It changes your attack surface, and you just have an easier way to get to stuff that is not available to the threat agent in China. But your threat agents in your corporate data center, or sorry, your corporate, intranet, they all become available, and they of course become the target of other types of attack. Because now I'm going to try to use them to do stuff for me. Okay. Of course, the people-driven subject matter experts, we're not all created equal. Two crypto experts are not going to be the same. Two HTTP experts are not the same. That's just, right, we're people. No two people are exactly alike. And even if it's the same person doing the same analysis, we have good days, we have bad days. We could do one analysis today, look at the same system a month from now, miss something today, see it tomorrow, see it today, miss it tomorrow. We're people. So just some general comments, because I know we've got to wrap up here. So what are some of the good things about tools? So speaking from the tools perspective, I can do anything that I've been programmed to do. I will do it consistently. I'm a tool. I'm software. I'm running. You give me some parameters. I will execute exactly what you told me to do. If you teach me something, I will look for it. I will look for it as often as you tell me to look for it, and I will do whatever my engine, whatever I'm capable of doing, assuming, of course, I don't have any bugs in my code, assuming I have all the resources to run, assuming all those other things that any piece of software needs to run. But at least I've got some consistency, and I've got all the intelligence of the vendor baked into this tool. That's really what you're getting with the tools, right? A bunch of security smarts. So what's not so good? Well, I will only do what I've been programmed to do. I will never do anything different. I will never do anything unique. I'm a tool. I'm going to do exactly what I've been told to do. And if you don't teach me how to do anything new, I will do what I was able to do out of the box. And that's like a death sentence for any tool. Static or dynamic, doesn't matter. You have to customize these things. So general comments about people. Well, on the good side, replacing the human brain is really hard. Right? We are great for thinking maliciously. We don't follow the rules, which of course a tool will do. A tool will follow all the rules that it's been programmed to do. People care less about rules. We're going to try different things. We're going to use things different ways. We're the ones that find those misuse and funny little abuse cases. That's the great thing about on the people side of things. And even two different people working, side by side, running similar types of tests, they're thinking differently. They're thinking about the problem differently. And of course, what's the bad things? Well, we are not machines. We don't have consistent results. We're not always going to do the same thing, test after test. We can't perform at the same level every day. It just doesn't happen, right? Again, we're people. And it is perfectly normal for two people to do the same types of tests on a system and find different results. It's perfectly normal for the same person to work on the same system at two different times and find different things. It's just the way it is. We're not going to find the same things. So, one last thing, at least with the three that we're talking about, these are finding defects in systems, but they are complementing each other in very different ways, right? Penetration testing is finding a class of defects basically in a deployed system. What's reachable by the attacker, what do they know about? The more it's white box testing, the more the attacker knows about the system, the better results you get, but they're attacking the system from a particular way. They're not going to find all the types of defects that a code review will find. A code review is only looking at the code. It doesn't understand where the software is deployed, it doesn't understand what may or may not be reachable. There could be a vulnerability in the code, but if there's no way to reach it, it's not interesting. Or if it's only reachable by the sysadmin, it's not interesting. Code review tools don't know that. And of course, the design review side is going to find basically flaws in the design. Highly unlikely the code review and pen test will find those. You can see that these all overlap to some degree. There is overlap. But if you think about a design flaw where an integrity control is being used where confidentiality control should be used, code is totally fine. Code review doesn't know it's the wrong control. It's perfectly safe code. Pen testers are not going to notice it's a confidentiality control instead of integrity control, most likely. Right? They're not going to notice that, but it's a totally broken design. It's the wrong control for what you're trying to achieve. You got to have a different type of analysis for that. So these all help each other. They find totally different things. It's a great place to start. Lots of tools for these two. Unfortunately, this is hard. You have to do it. They find some of the most valuable defects in software. And just to wrap things up, these are just 3 techniques of like 20. So again, these slides will be up there, so you can go back to slide 3 and see what the list of 20 was. But there were like 6 defect discovery ones. We talked about 3. There's still things like fuzzing and some other stuff. But even that was only part of a much bigger set of activities that you need to do, from things like guidance and metrics, and there's just a bunch of other stuff to do. So we kind of scratched the surface with these 3. It is a very common place to start, especially with things like code review and pen testing, because there are some free tools. There's some like reasonably cheap tools. We have folks that are getting actually pretty good results with things like Work Pro, if you know what you're doing. But of course, when you train yourself internally to use things like Work Pro, those are hard people to keep because they get pretty valuable skills. So you want to train them to be good at what they do, and when they get good at what they do, they aren't always your employee. But such is life, and it's the nature of the beast. So that was what I wanted to kind of zip through here. Questions, comments? I don't know how much time we have left. I assume we have a little bit more time.
So you've got about, I maybe slowed you down a little bit early, but you've got about 5 to 10 minutes.
Oh, okay. Questions about what people are doing. Like I said, these are 3 common places to start. A lot of tool support on pen testing and code review. Lots of options from $0 to lots and lots of dollars. You got to figure out what your development environment drives the tool choice you're gonna go after. How much you're willing to customize the tool should drive your selection. The very, very expensive tools allow some of the best customizing, but buying a super expensive tool and not customize it is dumb. It's just a waste of money. So the tools that are very expensive have high levels of customization capability, but if you're not going to invest the time to do that, waste of money, because the very expensive tools out of the box are not that much better than the tools that are way cheaper. They have the ability to be way better. You got to invest the time to make them way better. They're not going to be way better out of the box. Vendors that tell you that are full of shit. Sorry. That's just not true. You have to when they're customized, awesome. You got to invest the time to learn the internal programming language, customize it, lots of value. And then it still may not make sense for you. Again, if you're doing 2-hour releases, there are tools that will not work for you. They are very good at what they do. They are too slow to be done in 2 hours. You just have to change your mindset. It's like, well, we're going to do a scan, on whatever, Sunday. We'll get the results Monday or Tuesday. We know we've already done 12 releases. We're going to go back to any defect that we find from the Monday code base. We'll look at our Git repo and we'll fix the code. So you just have to change your mindset that the code you're working on Tuesday is the code that was scanned on Sunday. No, that won't be the case depending on your environment.
Have these tools integrated nicely ever with like a CI environment?
So I wish I had the current answer to that. I know we have folks that are looking at that are addressing that exact problem. It is, to my knowledge, it's not nicely integrated. You have to build your tools to basically work with the CI tools to integrate with CI. And then there are just some tools that are not good choices because their scan time is too long. Now they're getting better because they're obviously the big hitters are addressing this problem. They know that they're missing out on the CI revolution, and they want to play in the space because they want everyone's money, which is fine. I mean, it's good business. I mean, they have a good product, but they know that the product in its current form doesn't work in the CI world, and so they're doing things to to cache and basically keep track of what's changed? Can I keep, information about a scan that was done yesterday and that code hasn't changed? I can suck all that information to this scan right now. I don't have to rescan things. So they're doing things to make themselves better, but as far as I know, it's still way far behind. Yeah, from other stuff. Anything else? Bill?
Since you mentioned it a couple times, what was the last version you had taken a look at for the Microsoft Threat Model tool? I know it changed greatly in the last 2.5 years.
So the one that was released late last year, functionally, it did not change that much. It's got better output. It still does drive. You still put in the 4 types of data. conceptually, it's a slightly different UI, but behind the scenes, it's still, I don't know. I used the old one and I used the new one most recently. I didn't see a significant enough difference. It still generates a lot of, it generates a lot of stuff that you need to go verify, and you have to go just kind of tick off a couple hundred items that, interesting, not interesting. But it will produce the list of stuff you cannot forget to think about. Yeah, which is fine. You just need to be good at which components should I put into the diagram and which ones should not be in the diagram. The more you put in, the more work you have to do. Which are the data flows that matter, and you've got to be thinking in a data flow centric model. That's what they do. It's DFDs. So if you're thinking in pure data flow diagrams, it's an okay place to start. It just depends what you want to do. No matter what, somebody has to decide what's in, what's out. When is too deep? When have I gone too far? When have I not gone far enough? Where do you actually put the trust boundaries? Where are they really there? And people screw up trust boundaries pretty regularly. And when you screw up the trust boundaries, you start to assume too much or restrict too much. So getting the trust boundaries is kind of important.
So when you're building like a lot of microservices, that can get complex. How do you solve that?
So I don't know of a good solution for that. We've actually, we actually just did a threat model last year for a company that was using microservices in particular. Really what we did was we built a threat model for the standard microservice. There were assets and there were controls that were part of the microservice, and then when the microservice got instantiated, it pulled in other information live, and that was kind of runtime info, and we had assets that came in when they went live. I didn't find an easy way to stitch the two together other than when it's sitting over here in static mode, there are things we care about. Who can alter the image, who can basically do things to the non-running version of the service, and once it gets instantiated, and we take all that information and make it live and start pulling from other places. Well, how does the threat model change? We did it live. So I don't know of an easy way to visualize that anyway. It basically became, layers of controls. This happened to be in Rackspace with Cloud Foundry, so there were some controls of different layers. You keep track of those, but as soon as it became, an instantiated image, the universe changed. So it was a little bit tricky to kind of imagine what that looks like, because now your design is changing on the fly. Not that your design changes, but your risk profile changes on the fly, because there's assets and functionality that became live when the thing became active, and that was kind of an interesting problem. So there wasn't some tool that did that for us anyway, and I don't know if there is one. I don't know if somebody else has other experience with that, but that was how we had to deal with it. We had we had a couple of threat models for different parts, and sometimes a bigger threat model just included that little threat model. But it was kind of visualizing it on their own. There wasn't some magic way to say, take this threat model and suck it into here. And that's, I think, one of the shortcomings with the whole threat model space. Those tools, they don't exist. At least I haven't seen any. So, anything else? Okay.
Thank you.
Very good.